Hello students, I'm your course instructor Dr. Chaya BM. So in this video we'll be looking into module 5 part B, that is RTS development methodology. So the topics to be covered in this section are we need to see what is Yourdon method, Yourdon-Meller method and Hadley method. So the RTS development methodologies include basically three development methodologies. The first one is Yourdon methodology, Yourdon-Meller method and Hadley method. What is Yourdon methodology? So this is based on the structured methodology using data flow modeling techniques and the functional decompositions. And it also supports development from initial stage through the implementation. So we need to discuss what are the key ideas of Yourdon methodology. The first one is subdivision of system into activities. So you take any system, first we need to divide it into activities. Once you form into the systems into activities, so you need to form an hierarchical structure based upon the activities, and these activities which are in different hierarchy has to be separated, so based upon data and control flows. And it says that there is no commitment to a particular technology in case of Yourdon methodology, and the traceability between the specification, design and implementation is also one of the key idea of the Yourdon method. So in order to understand the RTS development methodologies, a general arrangement of a drying oven is understood in this concept. So what are the requirements of the drying oven? So what do you mean by a drying oven? To understand this, we need to go through the introduction part and input and output interfaces for the drying oven, and what are the functional specifications of the drying oven. So when we take any system, this systems will have so many tasks. So all these requirement definitions of drying oven is clearly understood in this video. The general arrangement of drying oven system is shown here. In this drying oven, the components are basically dried up by passing it through the conveyor belt like this. And in this setup we can see that the components are placed on the conveyor belt, which conveys slowly through the drying oven. This drying oven consists of three gas fired burners. We can see here there is a preheat burner, drying burner and a cooling burner. So these are monitored with different temperatures, and it is monitored by the thermocouples. So it basically does the temperature measurement. And also we can notice that the temperature at different burners can be monitored and controlled by operator console unit. I repeat, the temperature at different burners here can be monitored and controlled by operator console unit. The plant inputs are provided for the drying oven, which includes the thermocouples. The thermocouples are basically placed at the three heater areas, that is preheat, drying and cooling. The inputs are available as voltages, which is varying from 0 to 10 volts. The conveyor belt speed is also monitored. So this conveyor belt speed is measured by pulse counting system, which is referred to as con speed. There are three safety guards provided here. The first one is in guard, out guard and the drop guard. The in guard is acting like as an input gate, output gate, and drop ensures that the component is not dropped from the conveyor belt. These three guards are monitored and measured by a logic high signal, which indicates that these guards are locked. And at times, if the conveyor belt has to be halted for some reason, it is done by conveyor halt signal. The functional specifications of a drying oven are discussed here. So first a signal is the startup signal. The startup signal is initiated, which means that the operator checks if all the guards are locked, like in guard, out guard and drop guard, and then starts the conveyor. Because only if the guards are correctly locked, the heaters are switched on. The heaters are preheat, drying and cooling. Second signal is conveyor startup. This signal is initiated if all the heater areas are switched on. For example, if suppose the conveyor fails to reach the desired speed within 30 seconds. If this speed fails to reach within 30 seconds, so the conveyor fault signal is activated and it immediately stops the conveyor. One more important functionality is that the temperature monitoring of a drying oven. So this temperature monitoring at each heater areas is read at every 2-second interval. If the temperature in each heater area is varying for more than 5%, so every 2 seconds it is being monitored, and if it is varied for more than 5%, then the alarm signals have to be asserted. The control unit at each heater area uses the PID control algorithm, and we have one more function, that is conveyor failure. That is, if the conveyor fails to start, the operator can issue reset command, and then it shuts the whole system down. And we also have a conveyor pause signal. What do you mean by conveyor pause? It means that during normal running of a drying oven system, the operator can issue conveyor pause command. And it also has a stop command which turns off the heater and the conveyor. So these are the various functional specifications of the drying oven. The summary of the video is as follows. We looked into what are the key ideas of Yourdon methodology, general arrangements of the drying oven. So in that we looked into what are the 3 gas fired burners used, 3 safety guards used, and various signals like con speed, conveyor start signal, conveyor fault signal, halt signal and conveyor stop signal. Also we looked into conveyor pause and what are the display menus used in the drying oven. Thank you.